Hi again, welcome back. We are talking about finding a confidence interval for population mean mu. And in the last video, I introduced the general formula that you might use, which is a point estimate, the sample mean, plus or minus something called the margin of error. You know that x bar you compute from the sample data. N, which is part of the margin of error, you get also from the sample data. Sigma is a population parameter, and so that's something that would have to be given to you or really well known. So the only component that you don't know how to get at this point in time is Z star, which is the critical value. So talking about notation, Z star is the critical value. Confidence interval has to have a confidence level. So you are fairly confident, hopefully, that the interval you get is reliable, and you need to be able to quantify that confidence. And so you've got this notation, which is 1 minus alpha, the Greek symbol alpha, which represents your confidence level or level of confidence. They're one and the same. How do you get Z star? How do you get the critical value? The good news is that you're never going to calculate this. It's always looked up from a table. You just need to use the right table. In this case, it's the standard normal table, which if you have, great. If you don't, feel free to click this link and you could use my version of the standard normal table, which is what I give my students. Right. So let's continue on talking about how to get the critical value. Confidence interval in this course, it's always going to be perfectly in the middle of the distribution. And so all of your confidence is centered about 0, which is the mean of the standard normal distribution. If you have 1 minus alpha in the middle, and you know that the total area under the curve is 1, or 100%, then by symmetry, you have to have alpha over 2 in each of the tails, the left and the right side. And that's going to be important detail, because the table that I have, that I give my students and that I provided a link to before, should have a lovely little picture like this. And any good table, any good standard normal table is going to have a picture, maybe like that or a little different. And this picture tells you what the table shows you. So my table says, I give you z-scores, and I give you probabilities, and these probabilities are the probability of being less than the corresponding z-score. Less than that z-score that you look up or that you want. In our case, we want that z-score. So then, what is this table actually showing? How is it set up? So my table is set up like this. You've got a column that looks like this, where you've got z at the top, and you have single decimal places, such as 0.0, negative 0.1, negative 1.9, and it goes all the way down to negative 3.4. But standard practice for z-scores is that they should have 2 decimal places. I only wrote 1 decimal place, so where is that second decimal place? Believe it or not, it's the first row. So this first row looks like this. 0, 0, all the way through 0.09. And so we're going to make use of this first row and first column. The part I left out, which is right here, the main body of the table, is what's left. Z-scores and probabilities are related. I told you where the z-scores are, so this body is the probabilities. That's where the probabilities are, which is why if you're looking at the table and you're looking at the probabilities, you should see a couple things. One is there are 4 decimal places. 2, there's no negative values. And 3, there's no values greater than 1, which is required in order to be a true probability. It has to be a value between or equal to 0 and 1. So that's what I want you to take note of. Let's continue on. We still haven't found our critical value. We're going to do this through an example. I want a 95% confidence interval. So that means that 1 minus alpha is 0.95. And that means that if there's 95% in the middle, there has to be 5% outside of the middle, or 0.025 in one tail. And so a nice quick check is that if you draw a diagram like this, you've got 95%, 2.5% on each side. You add up those three numbers, it has to equal 100%. It has to. If it doesn't, something's wrong. So the critical values are these z stars, negative and positive z star, which corresponds to these locations here. And because this is standard normal, 0 is in the middle. Now, I personally only give my students the negative side of the standard normal table. So with that in mind, here's 0. I'm going to want my students to find this particular critical value. And since the table only gives less than probabilities, I want to look up this number of 0.025 in the table. Now, thankfully, this number actually exists in the table, and it's going to be located right about there. So look through the table, the link that I showed before, and see if you could find 0.0250. You should. It exactly fits in there. What you're going to do to get the critical value, the corresponding critical value that has 0.025 to the left of it, less than that value, is look at the corresponding row and look at the corresponding column. And what you should see is that the corresponding z-score is negative 1.96. Here's the second decimal place. And so finally, our answer is that z-star is 1.96. It's fine to leave the negative sign in there. If you want to make it positive, that's okay too. It really doesn't matter because when you actually plug into the margin of error formula and the confidence interval formula, it'll always work out. You're going to have one large value and one small value. Just make sure that you set your confidence interval up going from small to biggest, and everything will be wonderful. In the next video, I'm going to demonstrate an application of applying this to real data.